Okay, so we go over integration, and the question that we have is asking us to find the integral of 10x to the power 4 minus 4x plus 3 over x squared. Okay, so before I even start working on the question, it's very important that we understand what integration is all about. Maybe to some extent, someone is finding it difficult to find the difference between what you do when you're differentiating and what you do when you're integrating. So, just to focus on integration, we need to remind ourselves of this fact. When you have ax to the power n, a is a number, okay, and x is a variable, and n is the power. Okay, so when you're integrating, what you're going to have is something like you're going to have ax n plus 1. You're going to increase the power by 1. Okay, divide by n plus 1. You do the same. You do what you do to the power, you do the same on the denominator as well. Okay, so after you finish integrating, what you're going to have is a what? Is a c. You're going to add the c. That c stands for a constant value. Okay, so just to go back to just to stay like to go back a little bit behind when you're talking about differentiating, remember to say when you're differentiating a constant value, what you're going to get is a zero. So when you're integrating, you're going to get back the what? The constant. So it's more like integration is just the reverse of differentiating. And again, you can say differentiating is the reverse of um, integration. When you get a value, when you get something, let's say you get something like 2x. When you differentiate this, what you're going to get is a 2. When you integrate 2, what you're going to get is 2x. Okay, so that's something that we really need to understand. Okay, so getting to this question, so looking at the the arrangement of this part here, which is a fraction, it can be it can be a bit of like it can be slightly difficult for us to work with the variable which is x being on the denominator. So it's very important that we take it on the numerator. We like we write the reciprocal of that, but I'll not write the reciprocal of 3 over x squared. I'll write the reciprocal of 1 over x squared. Okay, so it's more like what I have is 3 multiplied by 1 over x to the power 2, like that. Okay, so I'm going to write the reciprocal of that, which is basically just this is going to give me 3 multiplied by x to the power negative 2. So this is going to be 3x to the power negative 2, like that, so that it will be much easier for me to work with. Okay, so what I'm going to have is a 10x to the power 4 minus 4x plus 3x to the power negative 2. Okay, so now we integrate that. So this is going to be 10x. You're going to have 4 plus 1. Okay, do the same on the denominator. 4 plus 1 here minus 4 here x. Remember to say here there is a 1, so this will be 1 plus 1 divide by 1 plus 1 plus 3x minus 2 plus 1 divide by minus 2 plus 1, like that. Okay, so what we get here, we're going to have something like 10x to the power 5 divide by 5 minus, you're going to have 4x to the power 2 divide by 2 plus, this will give us something like 3x minus 1 divide by minus 1. Okay, so we have seen to say there 5 can go into 5 one time, 5 can go into 10 twice, which is a 2. So 2 into 2 1, 2 into 4 2. So here negative 1 into negative 1, 1 into negative 1 is negative 1, and into 3 is negative 3. So we're going to have something like 2x to the power 5 uh, minus minus 2x squared. Okay, minus, this is going to be 3x to the power negative 1, like that. And that's what we get at the end. And remember to say we still have to add a c, and we don't have to leave a variable with a negative power on the numerator. We have to take care of that. Okay, just to put it there. Okay, So now what we are going to have in this case is that we're just going to write the reciprocal of x to the power negative 1. What you're going to get is 2x to the power 5 minus 2x to the power 2 minus 3 over x. So we get rid of the negative 1 by putting it on the denominator. So we're also going to add the what? A c. And this is the integral of what we have here. Okay, so there are a lot of things that you can do with there are a lot of there are a lot of things that you can do with integration, such as finding the area of a given. It's more like, let's say you're given a graph of this manner. Okay, so you're going to pick a value here and the value that is here. This can help you to do what? To find the area under this curve, something like that. So we're going to get the equation of the curve in these two values. So those two values are the ones whereby sometimes you find that they put them here, such as maybe they put a 0 here, there's a 0 there, then maybe let's just say x is 5, like that. So what you do is that you just integrate what you have. After integrating, you're going to subtract the smaller number from the bigger number by replacing where there's x with the what? With these two values. Okay, so it's more like you get you're going to get what we have integrated, the integral that we have gotten here, where is x we put 5, we put the value as, let me just say the value as z, minus, then you get the same integral again, where this x you put 0, you put the value here, let me just name it as y, then what you get is the area, and you just write it as what? In units, unit squared, like that. So there are a lot of things that you're able to do with integration, and this is basically how you go about answering that question. And not only finding for the area, there are times when they give you in such a manner, then they ask you to do what? To evaluate. And first of all, what you have to do is that integrate. Don't just get the equation the way it is and start replacing. No, do the integration and do the replacing afterwards. And it's very important that you do the integration correctly. Otherwise, what you're going to get at the end of the day when you start replacing for the values is going to be wrong. So that's how you go about answering such a question, and thank you very much for watching.